Polymers and plastics. Polymer is a long chain-like molecule formed of repeating units, and those units are called monomers. Mono means one. I should probably look up where mer came from, but polymer means many mers, and this is one mer. So we've got repeating units. Many biological molecules are polymers. So starches, cellulose, proteins, and things like enzymes are made of proteins. Your DNA is a polymer. So polymers are really important. There are also synthetic polymers. PVC, styrofoam, nylon, plexiglass, pretty much any plastic is going to be a polymer. They're durable because these long molecules have larger surface area, and so the dispersion forces holding them together are going to be stronger. So they tend to have higher melting points and boiling points than the individual monomers would. To break or tear a polymer, you either have to overcome the intermolecular forces or break the covalent bonds. And so they tend to be really strong. Polyethylene is one of the simplest synthetic polymers. So this is ethylene, and that's the monomer. And you take a bunch of these together, you add them together, and you get polyethylene. So you've got just this long carbon chain. This is called an addition polymer because when you put these together, you don't lose any atoms. You have the same number of carbon and hydrogen atoms. What's happening here is you're losing the double bond. It's going to a single bond, and that allows this to connect on both ends. But you don't lose any. So you're very distracted by the lemmings, aren't you?
They jump off in groups?
They jump off in groups, yes.
There's a gift. Look, you can see them all jumping.
So that's an addition polymer. There are different types of polyethylene. There's high density, there's low density. And with polymers, we don't talk about like a specific chemical formula, kind of like with the ceramics and those other atomic solids. You're not looking at necessarily a specific formula. We definitely have a ratio, an empirical formula, but when you make polyethylene, are all of the molecules exactly the same length? Probably not, right? But they're about the same, and depending on how you make it, you can make it have different qualities. So high-density polyethylene and low-density polyethylene differ in their density, right? One's high and one's low. What causes that? In high-density polyethylene, there's very little branching. There's no blanching, but there's very little branching in the chains. So the chains are mostly just long single chains. And those can nestle together very closely, and so that causes it to have a higher density. Low density is going to have more branching. So we're making these chains, but now they've got like arms and legs and things, branches like a tree sticking out, and they're not going to fit together very well. This reminds me of yard waste day, right? If you're cutting down stuff that just is these long sticks, you can bundle those up and get them in the bin, no problem. But if you're cutting off branches that have all these twigs and stuff, those don't go together very well, right? They take up a lot more space in the bin. So that's what the branched polymer does, is it just like doesn't fit together very well. And so it has a lower density. We use high-density polyethylene a lot in milk jugs. Low density is used in the formerly common plastic bags, the single-use plastic bags that we have to pay for now. Actually, they don't even sell those to us. They sell us the nicer ones. No comment. So you can take that polyethylene and you can modify it. Substituted polyethylenes, entire category or class of polyethylenes. Polyvinyl chloride is one of these. So we've got these ethene or ethylene monomers, but they've got a chlorine atom on them. And so when you put those together, you end up with this carbon backbone here, but every other carbon has a chlorine atom. So this is PVC, polyvinyl chloride, used for pipes and plumbing fixtures. I believe these, the DI water faucets here are made out of polyvinyl chloride. instead.
Are the new bags any more biodegradable?
I don't think the new bags are more biodegradable. The point of the new bags is that they're reusable.
Okay.
And you're supposed to use them over and over and over again. Of course, you know, how many years is it going to take before we actually remember to bring the bags into the store? Maybe when our cars become full of bags, we'll begin to remember. I don't know. Copolymers have different kinds of monomers, not just a single monomer, but they have 2 or more different kinds of monomers. So we have those monomers adding together via a condensation reaction. And then they form a dimer. So these 2 monomers can condense. Often a condensation involves the release of water. So when water, you know, when you see water vapor coming on a window or something, you say there's condensation on the inside of the window, right? The humidity inside's too high. Condensation. So a condensation reaction releases water, which could condense on your window. There's a relationship between those uses of condensation. So condensation polymer eliminates either an atom or a small group of atoms when it forms the polymer. So these 2 come together to form a dimer, and then those dimers polymerize into long chains. Condensation polymer. This is just a summary of some different types. And again, this is more for interest, for general awareness of, you know, being aware of how chemistry is involved in our everyday lives. All of these plastics are made possible because there are chemists figuring out how to make these things. Nylon is a condensation polymer. That's used in all kinds of things. You make carpets out of it, you can make clothing, fishing line, all sorts of different things. Polyester, there's lots of different forms of polyester, but that's in all kinds of things as well. Polyurethane is used in making like cushions and things. So again, you don't need to memorize that, but I would recommend understanding the terms, those bolded words.